Okay, today's lesson is worksheet 4.3. It's section number 2 or day number 2 on that section. And a typical problem for today is like cosine of 120. Let me show you how I did this one. Since I knew it was 120, this line had to go over to 120, but then I don't actually use that 120 in my answer. I actually use the reference angle, which was 60. Then, next thing is, if I know it's a 60 there, it had to be a 30 here, and it has to be a 90 here. And then I know the side ratios. It's 1, 2, and the square root of 3. And it was important to get that this was a negative 1, actually, because it's going this way. It's going to the left from the origin. All right, then, cosine of that is adjacent over hypotenuse. Here's the adjacent. Here's the hypotenuse. And it was negative 1 over 2, negative 1/2. All right, next, I'd like you to figure out cosine of 7 pi over 6. I'll give you a second to work on that. Okay, so let's try this one. Where is 7 pi over 6? Well, first of all, where's pi over 6? 1 pi over 6 is right here. 2 pi over 6, 3 pi over 6. This would be 6 pi over 6. So 7 pi over 6 would look a lot like that. Questions on that? That's where 7 pi over 6 is. Then I'm going to make my reference triangle that goes with that. And if this is a pi over 6, that's also known as a 30. If that's a 30, then this is the 1, 2, square root of 3 triangle. But don't forget the negatives. Which one of these are negative? That one's negative and that one's negative. The hypotenuse is never negative. All right. Next thing, if that's a 60, that's the right angle. Now what's the final answer? Cosine of that. Cosine of this angle right here. This is the key angle right there. That one's theta. Cosine of theta, adjacent over hypotenuse. Adjacent, negative root 3 over hypotenuse, 2. Negative root 3 over 2. Raise your hand if you had that one right. Awesome. Many of you had it right. So you're getting that first part. This first part ought to be relatively easy for you then. Now let's move on to the quadrantals. Quadrantals are where you are at one of these points right here, where it's one of those 0, 1, 1, 0, that kind of thing. So your angle has opened up to, like, let's say there. And let's say I asked you the sine of 90. In the past, we'd always say, oh, you can't do the 90-degree angle because, you know, we don't allow you to do that because then otherwise what's the opposite and what's the adjacent? They're like the same thing. Get the 90-degree angle. So we have to have a different way of doing this other than opposite over adjacent. So how do we do it? Well, this I need to give you a little background for. You need to understand where it's coming from. And I'd like you to just look at this slide right here and try to figure out why would the radius be 1 in the unit circle? What does unit mean? 1. So it makes sense, doesn't it? Why would that distance on the bottom there of that little triangle I drew be x? We don't know what it is, right? And it's the x distance, right? So we call that x. And how about the y? Does it make sense that that's the y distance? It's the up and down, right? Okay. Given all of that, you're going to find out something kind of surprising about what sine is. If I am at a place and on, like right here on this circle, if I did sine of theta, here's theta. What's sine again? What over what? Opposite over hypotenuse. So what is it in this case? Y over 1. And y over 1 is the same thing as y, right? So sine is the y. Sine is the y value. What does that mean? That means if I go look at these points, you know, 0, 1, 1, 0, negative 1, 0, 0, negative 1, the y is always the second coordinate of it, right? So can anybody answer for me now? What's the sine of 90 degrees? 1. It's just the y value. Because sine's y. Everybody say sine y. All right, that'll help stick it in your brain. And it sounds a lot better if you're muttering that going down the hall than the next one, which is that cosine is x. And you say cosex, and then you're like, what are you talking about? Anyway, so sine y. Remember that sine is y, and you'll remember that, oh, cosine's the x. And then there's only one other thing. Just in case I didn't tell you this, cosine. Cosine is x, but it's really, why is it x? Because it's cosine ka adjacent over hypotenuse. The adjacent side's x, hypotenuse side's 1. That's why cosine's x. So what's the last one? Tangent. What's tangent? It's opposite over adjacent, right? Y over x. Yep. So if you knew the y and you knew the x, you take the y and you divide it by the x. So at any of those points, at the quadrantals, you've always got like 0, 1, or 1, 0, or -1, 0, or 0, -1. Okay? And if I ask now for some of these rapid fire, you should be able to do them really easy. What's the sign right there? Sine is which one? Sine's y, and so it's -1. What's the sign right here? Sine is which one? It's the 0. It's the y of it. Okay, what's the sign here? What's the sign here? What's the cosine? Whoa, hold on. What's the cosine there? 0, it's the x. What's the cosine here? -1. What's the cosine here? What's cosine here? All right, then now this is harder. Remember, the tangent is which one over which one? Y over x. So right at this spot, what is the tangent of 0 degrees? 0 over 1. What is 0 over 1 equal to? 0. So we just figured out that the tangent of 0 degrees is 0. How about the tangent of 2 pi? It's the exact same spot, right? So it's the same answer, 0. Okay? I'm going to give you 3 questions now, and if you can get these 3 right, then you totally understand what's going on here. What is the sine of 3 pi over 2? What is the cosine of 180? And what is the tangent of pi over 2? All your answers should just be a number, like 2 or 1 or 0 or -1. Try it. If you're stuck on where 3 pi over 2 is, it's right there. Okay, sine of 3 pi over 2. Sine at this spot right here. The sine's the y, sine y. So the y is -1. So there you go, -1. Cosine at 180. Well, first of all, where's 180? There's 180. Cosine is the x. So x is -1, and therefore -1. And the last one, tangent of pi over 2. Here's pi over 2. Tangent is TOA, and opposite over adjacent. On the opposite side, there was 1 over, or sorry, y over x. So there we go. 1 over 0. Is 1 over 0 the one that's okay or not? You can't do that, can you? So what's the answer? It's not 1, and it's not 0. It's undefined. Undef. How many of you had all 3 of them right? Okay, good. I think you're getting quadrantals then. Now, there's a last topic, and it's kind of like logic. Let's just use logic for just a moment, not even about trig, but just use logic. ASTC. What if I told you that I knew I was in a quadrant, and I knew that that quadrant did not have a vowel in it, and it wasn't in the word rat. I was in a quadrant that didn't have a vowel in it. Okay, so wait a minute. Do you get which one I have to cross off now? A. And then I also said it was not in the word rat. So the T has to get crossed off too. So then it must have been either S or C, which would be either the second quadrant or the fourth quadrant. You can do that same kind of little logic game, except with trig, when they tell you something like this. Sine of my angle, I don't know what the angle is, but sine of the angle is positive, and the cosine of the angle is negative, can you figure out which quadrant you have to be in then? The way I like to do it is I like to cross off quadrants that don't qualify anymore. So if I know sine's positive, do you get that I can't be here and I can't be here? Just hold on. One thing at a time. So sine is positive. Do you get that I can't be in those two spots? You agree? Okay, good. Go ahead if you want to add more to that. That's okay. Yep. If sine was 0, just to clarify, is 0 positive or negative? It's neither, but then that would give you a hint that it must be on one of those lines. It must be one of the quadrantals then. Okay? All right. Quadrantals, don't think of them as in quadrants. No, they are not. They are not in quadrants. They are, yep. All right, so how about the other part? Cosine of theta is negative. Could it possibly be here? No, can't be there. Could it possibly be here? Is cosine going to be negative in there? Yeah, so it has to be there. So that's where I would draw my little triangle. And then I would say, okay, well then how many degrees is it, or tell me the sides or something, and they will tell you the sides. They'll tell you the sides like this. Let's say that they said it's 2 over square root of 3 or something like that. No, it doesn't work because the hypotenuse has to be bigger. I'm going to try that again. Root 3 over 2. That doesn't work either. I'm going to go root 3 over 1. Okay. Good. Do you get when I said sine is equal to root 3 over 1, I was also saying it was positive? Otherwise, I would have had to put a negative sign on it, right? So I'm telling you its sine is positive, and I'm telling you two sides. I'm telling you the opposite is square root of 3. So here's the opposite side from this angle. The opposite is square root of 3. Over the hypotenuse is 1. So that means this side right here has to be 1. And wait a minute, I think I screwed it up again. You can't have the hypotenuse. The 2 would have been better. I should have had stuck with the 2. Sorry. There. Okay. So what I'm trying to get at is the biggest thing in these problems is to use the little logic puzzle of which quadrant do you have to be in. All right, so here is a typical question. If cosine of theta is equal to 2/3, and here's another piece of the puzzle, and let's go with sine, and sine of theta is less than 0. Now I just told you what quadrant it has to be in. If cosine is positive, notice I'm going to put a little plus there. Positive 2/3. Do you get, if all students take calc, that if cosine has to be positive, it has to be in, it can't be here and it can't be here. It has to be in one of these two guys. We good so far? And then how about sine of theta being less than 0? If sine is negative, do you get it can't be here anymore? If sine's negative? So I'm left with only one place that this triangle can go, and it's right here. And therefore, you just draw yourself a kind of generic triangle. You put a theta right there. And now I use my sides it gave me. Cosine is adjacent over hypotenuse. The adjacent side's 2. The hypotenuse side is 3. Could you figure out that last side? Yes, you could, because it's 3 sides of a triangle. So you go square root of 3 squared is 9, 2 squared is 4. Do I go 9 plus 4 or 9 minus 4? 9 minus 4. 9 minus 4 would be 5, square root of 5. And this is where I made a mistake last hour. So easy to forget right there. Negative. It's a negative square root of 5. Because it's going down. See, it's going downwards. All right, so 2, 3, and negative square root of 5. There is no question, actually, on this problem yet. All I've told you is the 2 clues. The cosine of theta was 2/3, and that sine of theta is less than 0. What they would actually then ask you for is something like this. What's cotangent of theta? If they had just asked me tangent, that would have been easy. So why don't you just do tangent? And then what? Flip it. tangent of theta, tangent is opposite over adjacent, so tangent of this angle right here is opposite over adjacent, which would be this over this. So it's negative root 5 over 2, but that would be for tangent. So I want to flip that and therefore go 2 over negative root 5. You get that one? All right, I'm going to give you a worksheet now, and I'm going to do the first couple practice problems with you. And if you want more help individually, I'll be glad to do that too. But I'm going to pause for a second while I hand this out. Okay, so I got the worksheet out, and we're starting with number 1. And it says cosine of 120. First thing you're thinking is, where's 120? 120 is right there. And I don't actually use the 120, though. I use the 60. Wait a minute, we did this one in class, didn't we? All right, we can skip that one. We'll skip number 1 also. Let's go to number 3. It's a harder one anyway. Number 3 was secant of pi over 3. I'm right away switching that. I'm not doing pi over 3 because I like, since we're using 30, 60, 90 triangles, or 45, 45, 90s, I like to have the degrees in there. So what is it? Secant of what? 60. All right, so now I know I'm in a 30, 60, 90. So make my little 30, 60, 90. And it's just a plain old 60. I don't have to like find a reference angle because it just is what it is. This is 60, and this is 30, and this is 90. And then secant, I don't really like secant, so what am I going to do instead? Cosine. I'm going to do cosine of this, and I know the sides are 1, 2, and the square root of 3, and I'll be careful with my negatives. Is there any negatives I missed in there? No, because we're in the first quadrant. So then I'm going to do cosine of 60 and then flip it. 1 over the cosine of 60. Well, the cosine of 60 is adjacent over hypotenuse, which is 1 over 2. So my answer is 2 over 1. To 2? Yeah, I think so. All right. I think that front page is going to be really easy for you. So let's flip over and do instead, let's do number 13. On number 13, we have negative 450 degrees. I know where that is. Do you know where that is? Try to figure it out. Well, negative 360 is like this. So where's negative 450? You know what degrees we're at? Well, it's 450, but where's negative 450? It's right there. It's at the 90. So do you get when they asked you for sine, cosine, and tangent of this spot? Okay, you must be right. So I'm going 360 plus number 90 is, I think oh, I get it. It's negative 450. I should have written that down, sorry. So it's going this way is negative. So here's negative 360. And then I need to go another 90. So negative 450 is just like going down there, which is the same exact thing as if I had done 3 pi over 2 or negative or 270. Okay, anyway, what's important here is figure out A is the sine. You got to figure out sine of it. B is you got to figure out the cosine of it, and C is you got to figure out the tangent of it. And it is this point right here, which is what comma what? This is important now. 0 comma negative 1. Okay, so now sine's y, sine y. Sine's the y, so it's negative 1. Cosine is the x, so it's 0. And last, be careful with this one now. Tangent is y over x, so it's negative 1 over 0. So you are correct. You can't have a 0 on the bottom. So tangent is undef. All right, let's do one more together. I just skipped 19. Let's do 20. Problem 20. Cosine of theta and cotangent of theta is what we want to find. But they got to give me these clues first. Sine of theta is 1/4. So then I go, where is that? Well, I got to narrow it down. I go, all students take calc. And then I'm going to rule out some areas. If sine is positive, note This is a positive 1/4. That means it can't be here and it can't be here. Sine has to be in either A or S. Then it says tangent of theta is less than 0. This is an important clue. Where's tangent negative? Well, not there, because all things are positive there. So now I know where to draw my triangle. Once I have that narrowed down, I can say, okay, triangle has to be here. And if the sine is the opposite over the hypotenuse, opposite is 1, hypotenuse is 4, and I figure out that side's the square root of 4 squared is 16. I think it's 15, and it's really easy to make this mistake. Negative. Don't forget the negative, because it's going to the left. Next question. Yes, tangent is the y divided by the x, but you only use that if we're talking about being on a quadrantal, like one of these spots. There, 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 or there. You know what I'm talking about? Okay. That's the only time that that's important, is if you're on a quadrantal. So right now, if I'm going to do sine, it's just opposite over hypotenuse. Done. All right. So tangent of this angle was negative. All that really told me was it was a clue on what quadrant I was in. What do I actually have to answer on number 20? Cosine of theta and cotangent of theta. Cosine, cosine, ca. This angle. Cosine. Mr. BG. What's cosine of that? Yep. Because that was adjacent over the hypotenuse. And then the cotangent. Ooh, I don't like cotangent. What should I do instead of cotangent? Tangent. But then I got to remember to. Good. So what's tangent of theta? Tangent of theta is not negative anything yet. Tangent is what again? Opposite over adjacent. But then I'm going to flip it. Final answer? Negative root 15 over 1, but over 1 is kind of unnecessary, but you can put it. All right. Remember, these are giving you clues. This is a clue to what quadrant it's in. That's all you needed that for, is to tell you, oh, if tangent's negative, you're telling me that it can't be here and it can't be here. And if sine is positive, you're telling me it must be here because it can't be there. All right. That's the biggest new thing for the day, is like using the clues they give you to figure out what quadrant you must be in. Okay, and that's all I have for you for today.